Hey everybody, Tim the Tonepriest here. We're back at it with our 1960 RCA 189 Bravo amplifier.
RCA audio, careful, it'll even make your parents' music sound great.
2.1 system, left, right, and center channel bass. Single-ended with 6 PQ5s, also known as EL84 in the old world. Very happy with the response to the first video, so we're going to milk this one a little bit more. I'm going to go on with part 2. So what is in store here? The replacement 6 PQ5 arrived for the original tube that had internal shorts, so this guy can go back to the GA20. And check this out, hold on. So we need to start thinking about an enclosure for this thing because, you know, no self-respecting female wants this hunk of iron laying around their beautiful house. So we went down to Savers to see if we could find, you know, a wooden box of some sort to build an enclosure for this. And they kind of let us down a little bit. They didn't have a huge selection, but we found this little box here. Has a beautiful agricultural motif, and it almost fits. It's basically exactly the same width as this is from the flanges. So if we are to use this, we're going to have to get a film crew and cut a section out here and here, and then the flanges will fit, you know, perfectly from here to here. And then in this way, this will probably work. We'll have to make some access holes for all the that junk there. But until we can find something better, we're going to go with this. Porky Pig and dinner. So that's that. What else are we going to do? At the ending of part 1, I had mentioned that the output was kind of low. And on initial playing around, initial whatever, part of the problem was I was driving the MP3 device that is around here somewhere. Here it is, with an old cell phone, and that was basically half the problem. The other half was where are we at here? I think this guy, dirty pots, and possibly also dirty sockets. I forgot to clean the sockets and the tube pins and stuff in my haste to get this sucker up and running. But yeah, that's what we're going to do. We're going to go clean up all that crap, clean up all the pots. I'm going to go back under the hood. I want to replace a few more of the passive components. Get those up to code. Get it all nice and modern and, you know, make it reliable for the long term. And safe, you know. Got to think about safety as well. Safety third. So there's that. I'm going to spiff it up. Going to build an enclosure. And we'll have some fun. So if that all sounds interesting to you, I'm not sure why it would. But if it does, hang tight. Here we go. Alright, we have Mr. Soldering Iron warming up. First thing we're going to do here is we have this dual balance knob, pot, whatever you want to call it. One is for the left and right balance, and one is for the reverberation unit, I believe. But it's basically doing nothing right now. So we're going to get it out of there, because it's just taking up space.
I can't keep taking Mr. Worthy's money for doing nothing.
How much he pay you?
That's between him and me.
Highway robbery.
Yes, and you sure right about that.
And it's kind of neat. The front knob controls the rear pot, and the rear knob controls the front pot, but whatever. We don't mind a little confusion around here. It's our natural state. So yeah, that's the first thing we're going to do. Is we're going to take this guy out, clear up some space in here, because he's just causing problems. He needs to go. Can you see that? Don't need him no more. So he's going to go. And we may this is a long-term idea. When we get the subwoofer and the real speakers we're going to use with this, depending upon how it all sounds and whether or not we need to control the subwoofer volume, we may use the section of the pot as a subwoofer volume. If we can, if that's possible. I think it is. This thing's just going around in a loop. We're going to cut all this out, and we're just going to, where are they? They're right here. Just going to jump them and get rid of this big giant wire and get rid of this wire on the inside cable. Because they're just taking up space, and we are never going to use them. So, alright, that's step 1 of part 2. Cleaning up a little bit. Holy shit, look at that. How does this thing even work? Yikes. Alright, here we go. Alright, I got all this junk out of there, as we can see. And, Mr. Pointer, where are you? Here we are. Hard to see, but right here, this red wire and this yellow wire are jumpers. Jumpering, the connection that this guy was making here. I'll show you that on the schematic. Alright, and that was basically this guy. So the stuff was coming into a plug, and the plug went out of the chassis, wrapped around the chassis, and then plugged back into the chassis. And so it was basically just passing through, so we don't need all that crap. Alright, moving on. So when restoring any piece of vintage electronics gear, we know that for the most part, you know, something this old, 62 years old, the electrolytic capacitors need to be replaced, wax capacitors for sure, and then certain brands of nonpolar capacitors need to be replaced. And another common thing that needs to be replaced are carbon composition resistors. Over the years, they can have like internal cracks and voids develop, and you'll hear the like the frying bacon is actually arcing inside the resistor, which of course is not good. So those don't last forever. All resistors with age can, you know, fail, but these are especially prone to that. And in general, the plate load resistors, like this guy right here, the 100K, see he's handling high voltage, loading down the plate here. So these guys especially, we just want to go ahead and take them out, because if they haven't failed already, you know, it's just a matter of time. So I've already done that with as many as I could with the resistors I had in stock. So we're going to go ahead and make a shopping list, and, you know, we will do that when the parts arrive. So that's what I'm doing. And when I'm making out my shopping list, for the plate resistors, the ones that I'm going to replace, I'm going to get carbon film, which are these like beige ones right here. These big fat brown ones are carbon composition. These are carbon film. And the blue ones are metal foil or metal something. Blue and the gray, I believe, are generally some kind of metallic composition. Don't know off the top of my head. Go ahead and do your own research. But supposedly the carbon composition resistors have all the tone mojo, but they're not very robust and not very long lasting, relatively speaking. The metal ones, blue ones, are very robust, but supposedly they sound, what's the word I'm looking for? Like shit? I don't know how true that is. I don't know if anyone's done a side-by-side, you know, blind Pepsi challenge taste test type of thing. But I completely rebuilt the circuit on a Fender Bandmaster Silverface using nothing but metal resistors, and it sounds pretty good to me. So I'm going to go ahead and get metal film, because they're kind of a compromise. They're a little bit more robust, and supposedly the quality and tone is better than the metal ones. But again, this is all probably subjective marketing to mojo, audiophile, guitar player bullshit, but whatever. We'll play along. Alright, we are going to go ahead and clean up the internal workings of our potentiometers here. Going to use some deoxit. What we do with this is give it a little squirt. See how there's an opening in there to get to the internal parts. Little squirt there. Little squirt there. And then just move the knob back and forth its full range of motion several times. And that should hopefully help things out a bit. Fun stuff. So this guy here is the component selector switch. So you can select, oh, we got a glare, which device we're using, which is connected to our RCA inputs. And this is a little different. We can use some different stuff on this one. This is a mechanical device, not a, well, they're all mechanical, but this doesn't have like a graphite disc or graphite track. So we're going to use this stuff right here, the CRC QD registered trademark electronic cleaner. And we're just going to give it a little squirt on where the whatchamacallits are, the contacts are, and do the same thing, move it back and forth a couple of times, and that should hopefully make it good for another 62 years. Do you see all that? Probably not. Pretty cool, huh? Okie doke.
Guess what's under here? Is it a volleyball?
We got the replacement 6BQ5 on our Superior Instruments Company Model TV11 tube checker here. Right now we're doing the test for shorts and leaks. So when I flip these switches, the ones that are all the way down in the K position, I flip them up to the P position. If this light stays illuminated, there's a short. Except for pin 5, this guy here. This guy should stay on, but all these other 5 levers should not stay on. So let's do that. Good. Good. Stays on. Pin 5. That's good. All right. So far, so good. Now let's do the other test.
What does a yellow light mean?
All right. Now we have it set up for the quality test. And what we have done is we have thrown switch 2 into the P position. We've changed the load from all the way up to 3, as it says to do on the tube roll. Get the heaters heating. And now we flip this switch up to the regular position all the way up, and let's see what happens. Bam! Oh yeah, this sucker's NOS. Love it. All right, we got a good tube, good replacement tube.
Slow down. Okay. What? Yellow light mean?
All right, so we are going to clean out our tube sockets, insert the tubes again. And here is our new tube right here. And when you get a tube, you just want to inspect the pins to see if there's any corrosion or oxidation. Usually if there is, you'll see a bunch of buildup where the pin meets the glass. You'll see it start to get all yucky there. But these all look pretty good. So what we're going to do, the new tube tests the strongest, or stronger than the other 2 original tubes that I have. So we're going to put this guy in the center channel position. So we're going with the QD again. And I am not left-handed. Just going to give it a little squirt right at the socket. You don't have to kill it. And just insert and remove the tube a few times. And then call it good. Pretty simple stuff. A couple of things I forgot to mention. You probably don't want to do this while it's plugged in and turned on. Safety third. And since we like our new tube so much, we're going to go ahead and give the Seller a 5-star review. How about that? Alright, moving on. Of course, as soon as I put the tube checker away, the letter carrier drops off a package with some new tubes. New old tubes, GE box here. They bring good things to life. Right, here we are. Oh yeah, that ain't no GE.
Genuine RCA tubes.
That's what I'm talking about right there. We get ourselves a 6CA4 rectifier tube. I wonder what this could be for. Alright, before we do a whole bunch more work, we're going to go ahead and hook everything back up in tester. You don't want to completely rebuild the circuit and then plug it in and test it. You want to do a little bit of work, test, a little bit of work, test, a little bit of work, test. That way, if something isn't working right, you kind of have an idea of where to investigate. So what we did before we apply voltage to the plug, went ahead and we tried to make sure we got all the solder splash off that we created, gave it a good shake, gave it a good blow.
That's what she said.
And in the areas we were working over here, we want to make sure all the components that we had to move, so we get our soldering iron in there. You know, no leads are touching that shouldn't be, etc. And then we'll do one last test to make sure our solder connections held, because this was a real bear to get in there and solder stuff in. We'll make sure everything's still connected. They're connected good. Nice solid solder connections, and then we'll fire her up. See how our little updates work.
Your baby's out running around, hanging with the crowd. Who's the dirty low down? You know, I wonder who taught her how to talk like that. That big idea.
I don't know. It sounds pretty good to me. What do you think? Well, Skaggs likes it. Alright, so I'm in here testing voltages with the voltmeter. And everything looks good. Everything's just slightly high, which is expected because, you know, voltages from the wall back in the day. Where's the wall? It's around here somewhere. Voltages from the wall back in the day, you know, we're going to be 112 to 117-ish. And I'm pumping a straight $120 out of the variac into here. So, as you can see, for an example, they're expecting 200 volts here. We're at 209. And on the other side, they want 75. We have 88. So we're a little bit high there. And etc. 235 is what they want. They're getting 246. Screen supply, 265 or 274. And then the plates on the output tubes, they want 280, and we have 293. So what we'll probably end up doing is, it's kind of nice, before any of the output supplies on the power supply here, you know what I mean, you know what I'm trying to say, before we send any voltages out, they have a dropping resistor before everything, right after the rectifier diodes. So we'll take that 100 ohm and we'll do a little experimentation. We'll bump them up a little bit here and there and see if we can't get these closer to what they're expecting. Because again, we're still on the current limiter, so that's going to go up even a little bit more. Not much, but a little bit. That brings me to my next thing. I wanted to do a little deeper dive on the circuit for you, as much as, you know, my skill, experience, ability, and intelligence would allow. So I was running load lines on these tubes, and let me show you what's going on here. So look at this load line right here, this red line right here. That seems weird to me. Last night I was playing around with this calculator, learning how to use it, and I just plugged in the numbers from the print, and that's what I got. You know, and you'll notice that the current on a 6CG7, you know, compared to like a 6AX7, well, yeah, probably a 6AX7 if one exists, or a 12AX7, is much higher. In fact, let me put that side by side. So if we had a 12AX7 in this position instead of a 6CG7, this is what the load line would look like. Here's all the information there. You know, and it's only pulling whatever that is, 1.7 milliamps. And you can see, well, I'd have to show you on the data sheet. Anyway, a 6CG7, you know, runs at a much higher current operating point. So the way they're running it, like this is what your load line ends up looking like. And so, like I said, I was playing around with this calculator yesterday, and I just didn't believe it. You know, that just does not look right to me. But I just tested it in circuit, and that's the voltage drop over the cathode bias resistor, and 2.2 milliamps of current. So yeah, this is what we're doing. What that all means, I really don't know. If you're the type of person that does know what that means, then please, by all means, yeah, let us know. Cool stuff though, right? Here is the load line for the 6BQ5 out of focus EL84 tube. And yeah, that looks a little better. Looks nice and vertical. So whatever vertical means, I think if I read correctly, this is more headroom this way, and if it's this way, it's less headroom. I don't know. This is stuff I'm just starting to get into now, but for what it's worth, there it is. Alright, I was going through this circuit, and so I can try and understand what these tone packs do, or the tone sucking networks. And I was looking at the volume potentiometer, and I noticed they weren't grounded, which is probably why, even when the volume was all the way down, there was still some music coming out of it. So I jumped a jumper wire to ground, and now there's no volume when it's turned all the way down. Imagine that. Oh yeah, this is fun. Alright, so we're trying to learn about this tone stack here. And as far as I can tell, and I'm definitely no expert at this, it looks like the treble side is like a tone knob, in effect anyway, that you'd see on like an old Fender amplifier. But the bass side is like a Baxandall tone circuit. Alright, we have the tone circuit calculator here. And this is like the tone on a Princeton. And we have capacitor, resistor, capacitor. And it's not the exact same thing, but I've, simulated it the best I can. And as you can see, if you turn it all the way up, you get a little treble, but cutting it, it'll wipe it out. But again, the important part is the signal comes in, capacitor, get your potentiometer, capacitor. And that's what we have here. I better get Mr. Pointer so I don't electrocute myself. Signal comes in, capacitor, potentiometer, capacitor, ground. And if we play with this.
Behind the gun, I'll make my final stand.
Copyright strike. So that's that. Alright, here is the Baxandall with the 2 capacitor. Is that what it's called? Hold on. Let me not give you misinformation here. Passive dual bass capacitor Baxandall. So what we have here is the signal comes in, goes through a resistor, and then it hits the first capacitor, which is tied to the potentiometer on one end and the sweeper. And we have another capacitor on the sweeper in the other end, goes through another resistor out. And that's what we have here. Where did Mr. Pointer go? Mr. Pointer! Oh, Mr. Pointer's fired. There he is. You hired it back. So we come in, where are you? Through a resistor, and we have the first capacitor, which is tied to one end of the potentiometer and the sweeper. Then we have this second capacitor, which is tied to the sweeper, and then the other end goes through a resistor out to ground. And that's what we have there. So, interesting. I hope that's helpful for someone. I forgot to give you a demonstration of the bass tone knob. So it's, yeah, pretty active. Very usable. Trying to figure out what this does now here, this tone sucking network. It's this guy right here. It's tied to the volume pot. And as we can see, what I couldn't figure out before was on these volume pots, there are 2 taps on there. And they're going to 2 legs of this tone sucking network. Okay, so I've been playing around with this potentiometer with the 2 taps. It has a 84K and 168K tap out of it. And I was playing around with it with the multimeter, and I've got, one alligator clamp at the 84K tap. And no matter which lug I test at, it's essentially at 84K, even when turning the knob. Anywhere, wherever the knob is, whatever position the knob is, it still reads, essentially 84K. It moves a little bit, but I have no idea how they managed to do that, to get 84K from each individual lug out to that tap, but, there you are. So I don't fully understand it, and of course there's the 168K as well. And so the signal is coming out of the first preamp stage, goes to the tone stack, comes up to the volume knob. Some of the signal goes unobstructed right into the volume potentiometer. But you get this 220K resistor, so that's going to let a little bit down through here. But then you have, this guy here, the 84K tap. What is that, in series with it? Yeah, it's confusing. It's breaking my brain. But basically what I think it's doing is just some more tone shaping. Sending some signal into some RC networks. And shaping your tone. There you go. If I was more adventurous, I would disconnect that from there to see how it sounded. But, this thing's a bird's nest. So we'll just say that RCA knew what they were doing. And they thought this was a good thing.
Ask your RCA Victor dealer to demonstrate new total sound stereo.
So we won't mess with a good thing. Alright, moving on. So it comes out of the volume pot, goes through a 0.047 capacitor, which is about normal. And it comes down and goes through this plug, and this is the thing we bypassed today, so this is just jumped. And then it comes over here, and it can branch out. It can either go up this way, or it can go this way. If it goes up this way, we'll say this is the left channel, because it is. So this branch, it goes up here, and it goes through a 0027 micro capacitor. And that is going to shave a ton of the bass off, which is fine, because this is our left channel. And then the right channel is identical. So that's one way it can go out of that plug. And then the second way is both sides, left and right, are mixed here together to make a mono center channel. And there's no high-pass filtering capacitor here. It just goes straight in. And this is where you get the bass. Bass is cut off from this channel, but you're getting it through your center bass channel here. Does that make sense? High-pass filter. Not high-pass filter, it did. And goes through one more amplification stage or preamp stage through another 6CG7, and then out. Pretty simple stuff. No phase inverters. We're all single-ended here, and that's all she wrote. That's about the extent of my knowledge of this kind of stuff. But yeah, simple and elegant in its simplicity. Alright, here's something neat I noticed. I've read that one of the things with Class A single-ended amplifiers is they're always running full bore balls to the wall. So right now we get the volume turned all the way down. 120 volts from the wall. We're drawing 0.66 amps of current and a total power consumption of like 71.6 watts. This is from the wall. This is reading the draw from the variac. And if we crank the volume up, so when we get it cranked all the way up to the point of distortion, then we start, the numbers start going down. But they basically stay the same until we get to that point. So there you go. That's cool, I guess. I think it's cool. Alright, I think I'm going to end part 2 here. We need to place an order. We're going to order some speakers. Some nice ones. Well, respectable ones anyway. I just need to solder a ground there. We'll order a few more component parts in there. Part 3 will be constructing the enclosure. You know, originally I wanted to do some kind of steampunk thing, but who knows? You never know what we might come up with. So we'll, part 3, we will finish off the circuit, replacing the last few resistors, basically, it's all that's left. Securing everything up, cleaning up the bird's nest as best as possible. And then adding the speakers, possibly adding a volume for the center channel. And then building a cool enclosure that anyone would be proud to display in their living room. So I hope you enjoyed the video. Hope you learned something. I definitely did. And hope to see you in part 3.